So I want to do another video where I show you how to take the strain gauge design and add some other electronic features that might be useful for your project. This is for anybody who wants to go sort of above and beyond. Everything we do in this video you could do on a separate board or with separate electronics, but we're going to show you how to add it to the PCB. Sorry for my voice, I got a cold and I sound pretty bad, but the first thing we're going to do is right now we have a connector for our microcontroller that connects power, and it connects the data and clock, and it connects ground. If we want to add two LEDs, we're going to have to have two more pins so that the microcontroller can drive those LEDs. So the first thing we're going to do is remove this connector. So click it and hit delete. And then whenever I remove a component, I always like to update the PCB and have it removed so that it shows up as removed. Sometimes if you remove a component and replace it with something else, it confuses the software. I'm not sure if that's the case here, but as a general practice, a deletion step, do it, update, then go back and add the stuff back in. So we deleted that. We'll go update PCB. Yeah, it doesn't like that I have the floating nets, which is, it's good that it complains, but we're going to leave it. Oh, it said it wants to save first. Now update, and again, just keep going. So now it tells us, okay, here's all these changes. You're removing this component, and it's going to leave all these nets floating. Okay, so now it removed that connector right there. So it still left all the stuff in that bottom, in this bottom blue layer, but everything else is the connector itself is removed. So let's go back to our PCB. I'm going to do a red and a green LED. That could do, red and green LEDs are really nice for if you had a strain gauge, if you had the torque wrench, you could have it be green when the torque is too low or red when the torque is too high. If you have the desiccant cabinet, you could do it, it's green when the cabinet's dry, it's red when the cabinet's too moist, or it could be it's green when the cabinet's drying the stuff in the cabinet, it's red when it's doing a desiccant purge. There's lots of ways to do it, but we have to add those extra connectors. So I'm going to add a 6-pin header. So we're going to go back to LCSC, and we're going to search for a 6-pin connector. So header pins. I search for 1x06. Well, apparently we don't have any. Let's do, is it pin headers? No. Okay, so let's just do the, so the pitch we want to be pitch we want to be 2.54. That's our standard 0.1 inch. And we'll do 6 pins. We'll apply that. And we will sort by availability and again, we only sort by availability to see what's popular, just because that's more likely to actually show up in the library. So this thing, 6-pin male header, shows up in the library. That looks pretty good. We'll see if that's available. Yeah, it is. So we'll click it, we'll place that. So we'll just put that here. And luckily, I just moved that ground. I didn't realize it was going to be dead on, but I moved that ground. So now pins 4 and 5 are going to be pins for our LEDs. So let's find some LEDs. Now, for the most part with the LEDs, we have lots of LEDs. They can be these dome types, so you can see here this would be a dome type LED. We have those. We also have surface mount if it's 0603. So let's just do an 0603 red surface mount part. So we'll do place. So we'll just put that here. And then we'll also go back. Now the color ultimately doesn't matter, because if they have the same footprint, we can, as long as we know the LED we're putting there is a certain color, we can put that on there. But Yeah, so this is fine. LED 0603 green. Place. And slightly different labeling command, right? This one was labeled U. It probably should be labeled LED or D for diode, but whatever. It's labeled the way they labeled it. So we're going to wire these up to our 2 pins here. And then LEDs, you can't drive them directly with 5 volts. You always need a resistor with an LED to limit the current that flows through it. So normally, you know, the way you determine the resistor you need for the set current is, let's say your LED has a forward voltage of 2 volts and you're powering it with 5 volts. That means 2 volts will be dropped across the LED, 3 volts will be dropped across the resistor. You just need to choose a resistor so that with 3 volts across it, you have the desired current. So if we wanted 3 milliamps and we had 3 volts across a 2 volt LED, we need a 3K resistor. If we wanted, you know, I guess, no, 3 volts. If we wanted 1 milliamp, it would be a 3K resistor. If we had a 1K resistor, it would be 3 milliamps. That's not bad. Let's put a 1K resistor here. So these are inductors, R103. That looks, well, no, it's not quite what we want. This is not the best way to find this stuff. R0603, 1K, that looks good. Panasonic is a good brand. So we'll put one here and one here. And then we have to put grounds on each side here. So these are going to be driven, so this is going to be so that if the microcontroller is connected to pin 4 and it applies a high voltage to the pin, it'll drive this LED. If it's connected to pin 5 and it's a high voltage, it'll drive this LED. So quite often LEDs are low driven, so a lot of times you'll flip these in reverse, so you'll have power on one side and you'll drive them low, and that's just because microcontrollers tend to like driving things low rather than driving things high. For the Arduinos, though, they're fine. They're good up to 20 milliamps, so we should be fine with this. So now that we've made our changes to our schematic, we can save, and we can update the PCB and apply changes. Okay, so now it threw all this other stuff on there. And we're going to have to do some fiddling around now with this. Now, the first thing is this ground pour on the back, this blue thing here. So right now it is it's kind of getting in the way, and it should be fine if we move stuff, but there's probably a way to, yeah, so ultimately we'll say rebuild copper area. But for now, when we place this part, it's going to violate the rules here. So when as we place this part, it'll be a violation at first. Here is it? Oh, it's about right. So first it'll violate, and it shows a bunch of complaints here. It doesn't like a lot of what we just did because it's hitting that ground plane that we have here. But it's okay. So we're going to make our board a little bit bigger. We're going to take this ground plane, and we're also going to make the ground. Nope. Don't grab the dot. If you grab the dot, oh, maybe we need to grab the dots. If you grab the dot in the middle, it tends to break the middle. So we'll just do this. That looks right. Okay, so we moved that ground plane over. Now we got to put the LED somewhere. It doesn't really matter where. We do want to know which one is which, though. So let's go back, and we'll say, so U2 and R7. So we'll do that first. So R7 was this one. And it doesn't, again, because it doesn't matter where we put it. I don't want to mess with my name, is all. We'll just put it here. I don't want to mess with this too much. Oh, wait, it was LED. It was U2 is the first one, right? U2. let's just put them, you know, let's put them all the way over here because it doesn't really matter. This the other LED, and then the resistors for them. Okay, that should be fine. You know, let's swap this around. So the grounds are touching, just so if the grounds are near each other, it's going to be very easy to make this work. You know, and I'm just going to put them both like this. I'm going to realign them. Put them both like that. You know what? Why keep it so tight? We'll just put them down here. We'll be fine. Now the names I don't love, LED1 and U2, so I will eventually change those. Just because as a label, the fact that the fab had two different labels seems a little odd. I do like indicator LEDs to be near the edge of the board, though. They seem to be more likely to be visible if you leave them next to the board. So what we'll do then is we will route these, and I may have done these. Yeah, let's switch these around. Actually, I just want to get this out of the way. Okay. So we'll route these now really quick. We'll do place track. We could have done W. Oops. Our track size is still fat, so we'll go back to 0.254. And then to make my routing easier, I'm going to move these. This one will be here. This one will be here. So now I'll hit the W key. Got this one here. This one should be able to fit down here. Okay. And now we just have to connect the grounds to these LEDs. So as before, we'll just do a little stub out. Hit W again. You know, we'll stub these both out to the same ground connection. It'll be fine. Now you have to place a, I'll just Control C, Control V, that little ground via. That'll connect it to the bottom blue thing as soon as we reroute it. And then we should be good. Once we reroute this ground port, it should so it's saying this ground isn't connected, but that's because I moved the ground port on the bottom and I haven't refilled it yet. So if I rebuild the copper area, now it all should be okay. Okay. So now I want to change the names of these. So this is right now called LED1, and I think I just said this is going to be my red LED, and then U2, we'll just call it green. So GN, let's just for consistency, we'll call it RD. Okay. GN and RD. Check it on 3D view. Yeah. So now we have two LEDs on the bottom here, which if we drive these two pins, we'll be able to do that. Let's go back. And we want to add labels for here. So we moved our connector, so our ground is down here now. I'll just Control C, Control V. So this one will be green. This one will be red. We got space, we can do green. Okay. Looks fine. Okay, that looks good to me. The H2 is a little off here. Not a great spot for it. We'll just put it here, I guess. We don't need the header label anyway. Let's go back to the 3D view to update it. Nope. Maybe we have to go back. 3D view. Yeah, now it's updated. VCC data clock, green, red, ground. Looks good. Okay, so we added some LEDs now to our design. And now we would just go through the same process we did before. So the first thing we want to do is we want to do check DRC, check for any errors. There's no errors, which doesn't mean it's correct, but it means it's not correct. It's not guaranteed to not be correct. And again, if we wanted to send this out to fab, we would just do generate PCB fabrication file. And of course it wants us to save, which is probably a good idea. Generate PCB fabrication file. And then generate Gerber. And save it wherever we want. Now I'd want to go back, and if the naming convention I told you to follow had the dimensions, so if we go back to, so this would be 33 by 25 is what we call it, and whatever color we want. So I should have named it so that'd be it. Lund strain gauge with LED, 33 millimeters by 25 millimeters blue, 5. And then I'd just check it on OshPark, and I would upload it to the Canvas site, and then it would be fabricated. So probably I'd want to, there's other stuff I'd probably like to do to clean this up. Maybe move that over here. But I just wanted to show you can quickly modify the board to add extra features if you know you're going to want them. If there's something you think you might want to have on this PCB, I want you to really start thinking about your project design and think, okay, for the dry cabinet, what are you going to do? For the torque wrench, what are you going to do? And as you start thinking about what you'd like to have the design do, if you want to have it make a sound, if you want to have it turn on a light, if you want to have something else, as you start thinking about those things, if there's something simple that you think you could add to this custom PCB and you don't know how to do it, contact me and let me know, and I can help you out with that. So. But try to get this done early if you can, and we'll all get it turned in on Friday. Thank you.